All right, great. Well, greetings, everybody. Welcome. We come to our sixth class. Next week is going to be our last class. I mentioned on the bulletin board, please prepare a PowerPoint presentation between 12 to 15 slides, and be prepared to cover them in about 15 to 20 minutes. So there are four of you, so maximum 20 to hour and 20 minutes maximum, so I can have some time left of the lecture for that day. And when you have bring your PowerPoint presentation on you can use my computer, or if you want, you can use your computer, it doesn't matter. Probably it would be easier to send it to me, then I can download it, and then you can just use my computer, and we use share screen, and the online student can do the same. I will make it so that people can access to the share screen. Okay, let's start our time with prayer. Father God, we thank you for all the blessings that we have received from you and every day of our lives. Thank you for everything that we have learned so far as we come to the sixth session and we study geometry. Lord, help us to see your hand in the pattern of the geometrical shapes of this universe, and see your wisdom, see your beauty, and I appreciate that. Lord, we commit our time into your hand. I ask your blessing upon all these dear students, the one in the class and also the one online, both for this class and any other courses that you are taking. We commit our time to your hand. We ask your blessing. In Jesus' name we pray. Amen. Any question? Do you have any questions?
I have a question regarding the PowerPoint presentation.
Okay, go ahead.
I began doing it last Monday, and I continued today, and I have like probably 16
slides,
but I still have a lot of work to do. It might be like 30 slides.
Oh wow!
Because I'm going to go like one like philosopher, and then another, just like a brief overview as they search for the truth.
Okay. Yeah. And your chapter was which chapter? I forgot.
Chapter 2.
Chapter 2. Okay. That's okay, provided, I mean, if you could a little bit reduce it, it helps. If you can cut down a little bit so that you can finish everything in between about 20 minutes. Can you do that?
Yeah, the reason why it's like too long is because I don't use PowerPoint. I use another program. So if I want to add another like text, I have to add another line. So when I click, it's like text here, and text here, and text here.
Oh, okay.
But it doesn't apply.
Okay. Okay, as long as you can finish it in 20 minutes, yeah. I appreciate it. What program do you use?
I use Canva.
Oh, yeah. Yeah, that's good. It's very good. Okay, anything else? No? All right. And I also mentioned, please read all the chapters that are mentioned in the syllabus. And those extra videos that I have, they're helpful. Please watch them. They can help you in learning the subjects better. Today, we want to study about geometry, and these are all different geometrical shapes and measurement, but we start very simple with the basic ideas. The point, line segments, ray, and a line. Point, as you can see, this dimension is 0, but the graphic is just a dot. Symbol is like a capital letter A. A line segment, it's a segment of a line. So you have, like, as you can see in the PowerPoint, you have a segment of a line. This is a line AB, or it can be BA, doesn't matter, but it's only one segment. So you have two dots, so solid dots, and then the line in between. The array is when one side has an arrow, has a flash sign. And then when you write it is AB with a flash sign going from A to B. And then the line is one line, and then it has the two flashes on the end. It continues. So you can see, like here, we have MN is it's a line segment. This is a plane, and they intersect. Okay, like this one could be line CD or BA or AB, doesn't matter. And that's their intersection point. Okay. What you're going to learn in this session and from the chapter is how to identify and model point lines and planes, how to identify collinear and coplanar points and intersecting lines and planes in a space. So let's start with the first part, the point. Point is a location, which is, as you can see, we have that solid dot and then a letter. A location represented by a capital letter or small dot, has no size, length, width, or thickness. Okay. Point is simply a location. Draw your attention to a location. Draw it with a dot, as you can see here in the PowerPoint. Notice. And name it with a capital printed letter. That you have 26 choices, like dot A or whatever, or dot P. It has no shape, no thickness, no width, no length, therefore it has no dimension. And we use words and symbols. The symbol is the dot, the word we use just called P. Line is a series of points that extends into opposite direction without ends. So here we have this is a line, it goes that direction and that direction. We identify 2 points on it, and we call this line AB or BA, doesn't matter. Now, but in order to make sure that it's a line, you write AB and then you draw a line above it with 2 flashes at the very end. We can or also call it line M, for example, as you can see here. Line made of points. Draw it with the arrow, as you can see here. But you need to have, the flash, the arrows on both sides. Name it with 2 points on it. So this would be line AB. With 2 points on the line, a lowercase letter, again, you have 26. You can call the whole thing like a little n, use a little n cursive, but also you can identify with 2 points on it and then draw the line above it. So it's either line, you can call it line AB or line BA. You can call it with the letter N, small n, or call it AB or BA. But again, you need to have the arrow at the top of these things, okay, with 2 flashes. as you can see here. And okay, collinear points are points that are that lie on the same line. So A and B are collinear. Okay, points that lie on the same line, they are called collinear. Like here, A, C, and B are collinear, but D is not. It's not on the same line. All right. Then here, if you have this figure, are there points of collinear here? If so, name them and name the line on which they lie. For example, are AD and E collinear? Let's see. This is A. Okay, here. This is A. This is this is point E and point E. No, they are not. Are BCD collinear? B. Oh, well, it doesn't show the points. I want to see the point. Okay. Well, if these are supposed to be these points, yes, you can say BCD are collinear, and AEC, you can call that collinear too. Okay. I have to correct that because the point should show. And you can name line M in 3 ways. This is, that line M. You can call it using point AGE or EGA or GAE, doesn't matter. All right. Now, what's a plane? It's a flat surface that has no thickness. It contains many lines and extends without end in the direction of all the lines. It is named either by a single capital letter or by at least 3 coplanar points. And coplanar are the points that are on the same plane. The page of a book resembles a plane, although it doesn't extend indefinitely and it does have thickness, but it can represent a plane. All right. Plane is a flat surface made of points like this. This is called a plane, flat surface, and draw it with a shaded or slanted 4-sided figure. Name it. You can name it with 3 coplanar points. This is a plane ACT. Okay, with 3 coplanar, non-collinear, shouldn't be on the same line, and they are not. So you can use hi. Oh, okay.
You can just leave it here.
Oh, okay. These are those letters. Oh, thank you.
Yes.
Thank you very much.
I'll pick them up tomorrow morning. Just
Okay.
leave it here.
Sure. So they have to be named by 3 non-collinear. So we can call this plane ATC, but I cannot use like AC because this would be collinear, or I cannot use just AT first because then the AT and something else you will collinear. But these 3 points, this one, and this one, are not collinear. So I can call this plane B. I use a letter B cursive with 3 non-collinear points, A, C, and T. All right. There's exactly one plane that goes through these three non-collinear points. So we can call this plane CAT, C-A-T, and or with one letter cursive B. Okay. Coplanar points are points that lie on the same plane. So all those points, they are coplanar, but they are not collinear. Points and lines that lie in the same planes are called this coplanar. If there is a line that is intersecting like this one, that where it crosses the plane, it's the points of intersection. Oh, you know, there is a book. It's out of print, but you can maybe find it from Amazon or something. It's called Poetry of Mathematics, and I remember I read that years ago, and I liked it. It's an interesting puzzle in it. Let me ask you this question. Let's say there are two parallel lines, as you can see here. Which of these two lines, you know, line AB and CD, which one has more points when you look at this shape?
Both are the same?
They're what?
They both have the same?
Exactly. Why?
Because I just like what A, B, and C, D.
No. Well, but remember, now that's just for naming them. But there are points. You know, a line is made of a bunch of points. Okay, so
Okay.
which one? Which one has more points?
If they have the same, I don't know why.
The same. Why do you think it's the same?
I don't know, like.
Well, you're right. They have the same number of
Right.
points because for any point here, I can find one point here and I can cross it. So pick any points on these lines, I can find a corresponding points here and I cross it. Because they are both have infinite number of points. You see, when you come to areas of infinity, things changes.
I was about to say that. But I didn't. Also,
Yeah.
expect reasons.
So that's interesting. So plane, like as you can see in this example, name the plane represented by each surface box. You know, let's do it here. Now, I know our eyes can play a trick on us. So this solid line, let's say this is the front, this is the front one. If I want to name it, it would be DHTI or IDH. You know, you can start from any of these 4 points and just make sure that you include all the 4 points. Okay. The back is that solid gray, MARN. This side is DMNI and this side is HART. The top is DMAH. The bottom is NITR. And I know our eyes play a trick when you look at it. Okay. Coplanar points and line that lie in the same plane are called coplanar. These are coplanar. These are coplanar line. These are coplanar point. This is not. This crosses the plane. Let's talk about angles. We have different kind of angles. Right angle is 90-degree. Angles are measured in degree, like 90, and then you put a little circle above it. Acute angle is less than 90. Obtuse angle is more than 90 but less than 180. Complementary angles are two angles when you add them up, they add up to 90 degrees. Straight angles, 1/2 a composition, complete rotation, basically is a straight line and you have 180. I will show you the figures. Supplementary angles are two angles when you add them up, they add up to 180. And here's the figure. You can see. This is this right angle. You have 90-degree angle ABC. So it's the point here will be in the middle. This one is an acute angle ABC because it's less than 90. This is obtuse angle ABC is more than 90 but less than 180. This is a straight angle, just straight line 180. And you see, for example, this is an obtuse angle. The other side of it would be, it's called the reflex angle. The whole thing is 360. So if I take, if this one is, let's say, assume is 135, then that one, or if this one is 220, this one should be 140 here inside. Okay. When you have two angles that they add up, become 90 degrees, they're called supplementary angles. If I have 245 degrees. Complete. Oh no, I'm sorry. That's they add up. They become 180 degrees. These are complementary angles. When they add up, when you add these two angles together, they become a right angle. Okay. Now, parallel lines are lines that lie in the same plane, have no points in common. If two different lines in the same planes are not parallel, they cross each other. They have a single point in common, and that's called intersecting line. If the line intersect at the angle of 90 degrees, then we say that line is perpendicular line to the plane. If we intersect a pair of parallel lines with a third line, then they are called what we create 8 transversal angles. Let me show you the picture so you understand better. Here, you see, we have two parallel lines, line A and line M, and then line T crosses it, and that creates 8 transversal angles. The characteristic of these that helps you in exam quizzes, for example, angle 2 and angle 3 are equal. 1 and 4 are equal. 6 and 7 are equal. 5 and 8 are equal. Okay. Let's look at page 538. So you can see that on page 138, but let's look at the first exercise 11. If you have a right angle and one of the angles, here you have two obtuse angles. One is 25, the other one should be 65. So you just subtract from 90. Look at number 25. You have two lines crossing each other. If the angle number 4 is 72 degrees, what is angle number 2? 72. And once you have that, you can find what's angle number 1. How can we find number 1?
we subtract 72 from 180.
Yes, that's right.
Does that
Because-
apply to everything?
I'm sorry.
Does that apply to everything?
Yeah,
too?
yeah, as long as you have this kind of shape, that there are two straight lines crossing each other, they have one intersection, then it does apply. But let's look at number 27. You know, it has given us that angle 40, so that tells me that the other side, the transversal of that is also 40. And I also know there's a right angle there. So 90 plus 40 is 130. So what should be number one?
50.
50, yeah. So then what should be number three?
40.
No,
50.
50. What should be number two?
40.
No,
50.
90.
Oh, yeah, 90. It is inverted. Oh, and it's like 92.
Okay.
Yeah, 90.
Look at number 32. Okay, if you have that at the top, you have that right angle, what should be number one?
Wait,
No.
90.
90. 90. Yeah, because it's exactly transversal of that angle. Now, if that is 90 and the one next to it is 40, we get 130. What should be number two? Subtract from 180, 50. Now, can we find the angles on the bottom line? You know, you can, because angle number 2 and angle number 3 are equal when you have parallel lines. Okay, it applies only when you have parallel lines and a line crossing. All right, you see what I mean? Yeah, let me write here. If I have two lines that they are parallel, doesn't have to be equal sides. Actually, they're both even. And something like this, another third line crosses it. This is equal to that, but also at the same time, these two are equal.
Okay.
All right. So let's continue. So here, when we come to triangles, we have different type of triangles based upon their angles. The angles inside are called interior angles. The one outside, like this one, is called exterior angle. And again, this one is equal to A. Yeah, this don't show. Okay. So different types of angles and triangles. So here, you know, here we have, when we have, we have an acute triangle, all angles measure less than 90. Okay, they add up to 180 degrees, but they are all less than 90. So because they all are acute angles, it's called the acute triangle. Okay. This one has a right angle, so it's called right triangle. This one doesn't show that well. Yeah, assume this is a little bit larger, bigger than 90. Okay. Then it's obtuse angle. It's called obtuse triangle. So there are three types of angles. There are three main types of triangles. When you have all sides equal and all the angles are equal, it's called equilateral triangles. When there are only two sides are equal, it's called isosceles triangle. when no side or angles are equal, it's called scale and triangle. Okay, and when you have a right angle, it's called a right triangle. All right. So let's go to page 541, examples 1 and 2. You know, we have that figure 10.16. It has given us, you know, this is all the sides are different, all the angles are different, but they have given us 2 of the angles. They want us to find angle number A. We don't know that. We know that this is the rule: the sum of all the angles in any kind of triangle adds up to 180 degrees. So you just add A is A plus 120 plus 117 should be 180 degrees. You solve it for A should be 43. Look at example number 2. In that figure 10.17, okay, we have, let's look at that triangle which is at the below the line. We have one of the angle 40 degrees. What's angle number 1? 90. So 90 plus 43 degree plus angle number 2, which we don't know what that is, should add up to 180. So when you solve that for angle number 2, it ends up to be 47 degrees. Once you get that, what's angle number 3? 47 degrees. So you have 60 plus 47. Now you can find angle number 4, which becomes 73 degrees. Okay, and then when you have 73 degrees, what's angle number 5? From 180. That's it. Okay, let's go to page 542, 543. Okay, I mean, it talks about similar triangles. Let's look at example number 3. Explain why the triangle 10.19 are similar, then find the missing length x. Figure 10 point, okay, solution. Figure 10.20 shows that the 2 angles of the small angles are equal in measure to the 2 angles of the larger triangle. Okay, we have 7 inches. Those are fine. You know. Okay, you see that? Look at figure 10.19. All right, maybe I better write on the board. Makes more sense. If when they talk about similar triangle, they don't mean that they are equal. What by similarity, they mean that they're the proportion, they are proportional to one another. So let's look at this one. You know, we have this line goes here, then we have that, then we have this comes here, and then it goes here. Okay. And we have this side is 7 inches. This side is 5 inches. Oh, well, assume it's 5 inches. Okay. And then This one is 8, okay? We want to find the angles. First of all, we can tell, you see this angle, there's this, I can draw a line, cross it, and a line cross it here. Cross this line, okay? And these two are parallel lines. Can you see that? Okay, and this line has crossed it. This one. So, if I have this kind of situation, this angle is equal to this. Yes? Therefore, this one is equal, these two are equal, or these two are equal. So this angle and this angle are equal. Then, how about here? These two are also equal. So I have two equal angles. And therefore, I can say that, you look at the answer, it shows that the two angles of the small triangle are equal in measure to two angles of the large triangle. One angle pair is given to have the same measure. Another angle pair consists of the vertical angles with the same measure. Thus, the triangles are similar and their corresponding sides are proportional, meaning side 5, this side over this side of the equal angles. 5/8 is equal to side 7/x. If this is 7 and x is this side. So we can find x. You follow me? Because this is in front of that, and that is in front of that. So say 5/8 is equal to 7/x. You follow me? Okay. You have to make sure that you're taking a side that is in front of the equal angles. Now, let's go. Okay, yeah, this is an example. Okay, look at example number 4 on page 544. It says a man who is 6 feet tall is standing 100 feet. So that man is 6 feet, standing 100 feet from a base of a lamppost. The man's shadow has a length of 4 feet. So if we make a triangle, it asks us how tall is the lamppost, okay? So we have 10 feet here, and then the 4 feet is the shadow. So that side is 14 feet. All right. Now, we can say again, if you assume that line, where that guy is parallel to the lamppost, okay? They cross that other side, okay? You follow me?
Yeah.
Maybe I can draw it. Okay, now we can use again the law of similarities of the triangle. In fact, here it's you have small triangle within a larger triangle. Now, I better draw it. So let's say this is the lamppost, okay? This is where this guy is standing. Here. And this is his shadow, 4 feet. And then if I connect this here, okay, this is a guy that's standing, that red line, okay? I can assume that's just a line and just continue that. So I have a line here, and I have this purple line here. Okay? So I have two triangles. One is a larger one, and one is this area here. Okay? They share a common angle. Okay? We know how tall is this guy? It's 6 feet. Okay. So he's 6 feet. We want to find x, and also we know this is 4 feet, and he's standing, I think, 10 feet. Yeah. Okay. So this side is 14 feet. Okay. So we have this side 14 feet. Now I can use, because they are similar triangle. They have two angles. One, this is common, and this one is a right triangle, and this one is a right triangle. Okay. So I can say the proportion of 6 over x is equal to, and this line, this angle, and this angles are equal. Okay. Yes, all right, because these two are equal. So that one, these two should be equal. So is equal to 4 over, where is it? 4 over 14. 14. Okay, did I get it right? 14, or other way around.
It's right, because
Yeah.
reverse, right?
Yeah, you just reversed it.
Yeah.
Or you can say, the book says x over 6 is same as 14 over 4. They're the same. So then you remember this multiplied by that is equal to that. So you get 4x is equal to 14 times 6, which would be 84. Okay, and then divide both sides by 4, x is 21. So this is, you see, one angle is this big one. But then you have within that this smaller triangle, and they are similar because they have these two angles are right angles, and this is common, so they are similar. And then these two angles are equal, and then we can use the law of similarities by using proportion, finding that the length of that pole. Okay. Let's go to okay, no, let's continue. Now, we talked about this, I think, in our first session, the Pythagorean theorem, that the sum of the square of the length of the legs of a right triangle equals the square of the length of the hypotenuse. So in that figure, as you can see, it's saying 4 squared 16, 3 squared 19 is equal to 5 squared 25. All right. Or in other words, if you add these two circles, you get this larger circle. Okay. Again, same idea. x squared is equal to a squared plus b squared. Area of A is red area plus blue area gives you the gray area. We talked about this, but I'd like you to see that short video again. So let's just watch this.
This video, we're going to get introduced to the Pythagorean theorem.
Let me.
Pythagorean theorem, which is fun
Come
on
on,
its own,
those
but you'll see as you learn more and more math. Like it's one of those cornerstone theorems of really all of math. It's useful in geometry. It's kind of the backbone of trigonometry. You're also going to use it to calculate distances between points. So it's a good thing to really make sure we know well. So let's not talk about Pythagorean. So if we have a triangle, and the triangle has to be a right triangle. It has to be a right triangle, which means that one of the three angles of the triangle has to be 90 degrees. And you specify that it's 90 degrees by drawing a box right there. So that right there is the different part. That right there
Trying to raise the volume.
90 degree, or we can call it a right,
Oh, perhaps this is the-
a right,
perhaps
a
the-
triangle that has a right.
Oh,
It is
I agree, well,
you're right.
like triangle. Now, with the Pythagorean theorem, we know sides of the right, we can always figure out the third side. Before I show you how to do that, let me give you one more piece of terminology. Side of a Pythagorean, of a
Oh, I did something.
scheme, both something
No.
else. Getting covered in caramel and on board.
Sorry. Yeah,
I think it's like the
yeah.
other.
Sorry.
You need help?
Huh?
Let me help
Yeah,
you.
yeah, thank you.
Don't worry, don't worry. Okay. I think it is in. Oh, well, it's already on the last.
No, I tried to put it to the back so they get my face. Laid in the dirt.
Oh. Oh, let me stop.
Okay, I see now.
Okay, I think I know.
It's in source.
Yeah, can I have that?
Yeah.
Sure. So let's
Oh, you don't have that.
go to here. No. Go home. Then go to
Source.
setting for source.
Source. And then go to, I think it's PC.
This
It's
one.
nice PC two.
Oh, no.
That's the other one.
Okay. So let's go home. Then go to source. This one. Oh,
And then I know how to like look at the sound.
yeah.
It is towards like upwards. It is.
Oh,
It
okay.
is. It's kind of weird, but yeah.
Yeah. All right. Sorry about that, guys.
No, no problem.
Triangle, and this
So let me actually go back. And start here.
In this video, we're going to get introduced to the Pythagorean theorem. Pythagorean theorem, which is fun owned, but you'll see as you learn more and more mathematics. One of those
accessibility shortcuts, 17 items, voice guide.
geometry is kind of the backbone of
Voice guide,
trigonometry.
clone,
We're also going to use it to calculate
HDMI to PC.
rates. So it's a good thing to really make sure we know well. So let enough talk on my end. Let me tell you what the Pythagorean
raise the
theorem
volume?
is. So if we have a
Okay.
triangle,
Let me
and the
finish.
triangle has to be a right
Just let them
triangle.
today.
So it has to be a right
Yeah, like,
triangle,
yeah.
which means that one of the three
Outwards,
angles in the
like that.
triangle
Oh.
have to be 90 degrees. And
Volume 59.
90 degrees by drawing
Okay.
that little box right there. So
Nice.
that right there is
Volume 72.
that right there is a 90 degree angle, or we could call it a right angle. And a triangle that has a right angle in it is called a right triangle. So this is called a right triangle. Now, with the Pythagorean theorem, if we know two sides of a right triangle, we can always figure out the third side. And before I show you how to do that, let me give you one more piece of terminology. The longest side of a Pythagorean of a right triangle is the side opposite the 90 degree angle, or opposite the right angle. So in this case, it is this side right here. This is the longest side. The way to figure out where that right triangle is, and it opens into that longest side. That longest side is called the hypotenuse. Hypotenuse. And it's good to know because we'll keep referring to it. And I just so we always are good at identifying the hypotenuse, let me draw a couple of more right triangles. So let's say I have a triangle that looks like that. A triangle that looks, let me draw it a little bit nicer. So let's say I have a triangle that looks like that. And I were to tell you that this angle right here is 90 degrees. In this situation, this is the hypotenuse because it is opposite the 90 degree angle. It is the longest side. Let me do one more just so that we're good at recognizing the hypotenuse. So let's say that that is my triangle, and this is the 90 degree angle right there. And I think you know how to do this already. You go right, what it opens into, that is the hypotenuse. That is the longest side. The longest side. So that is the hypotenuse. So once you have identified the hypotenuse, and let's say that that has length c, and now we're going to learn what the Pythagorean theorem tells us. So let's say that c is equal to the length of the hypotenuse. So let's call this c. That side is c. Let's call this side right over here. Let's call this side right over here A. And let's call this side over here B. So the Pythagorean theorem tells us that A squared, so one of the shorter sides, the length of one of the shorter sides squared, plus the length of the other shorter side squared, is going to be equal to the length of the hypotenuse squared. Now, let's do that with an actual problem, and you'll see that it's actually not so bad. So let's say that I have a triangle that looks like this. Let me draw it. Let's say that this is my triangle. Looks something like this. And let's say that they tell us that this is the right angle, that this length right here, let me do this in different colors. This length right here is 3, and that this length right here is 4. And they want us to figure out that length right there. Now, the first thing you want to do before you even apply the Pythagorean theorem is to make sure you have your hypotenuse straight. You make sure you know what you're solving for. And in this circumstance, we're solving for the hypotenuse. And we know that because this side over here, it is the side opposite the right angle. If we look at the Pythagorean theorem, this is C. This is the longest side. So now we're ready to apply. We're ready to apply the Pythagorean theorem. It tells us that 4 squared, one of the shorter sides, plus 3 squared, the square of another of the shorter sides is going to be equal to this longer side squared. The hypotenuse squared is going to be equal to c squared. And then you just solve for c. So 4 squared is the same thing as 4 times 4. That is 16. And 3 squared is the same thing as 3 times 3. So that is 9. And that is going to be equal to c squared. Now, what is 16 plus 9? It's 25. So 25 is equal to c squared. And we could take the positive square root of both sides. C, I guess, just if you look at it mathematically, could be -5 as well, but we're dealing with distances, so we only care about the positive roots. So you take the principal root of both sides, and you get 5 is equal to c, or the length of the longest side is equal to 5. Now, you could use a Pythagorean theorem if we give you 2 of the sides to figure out the third side, no matter what the third side is. So let's do another one right over here. Let's say that our triangle looks like, something like, our triangle looks like this. And that is our right angle. Let's say that this side over here has length 12. And let's say that this side over here has length 6. And we want to figure out this length right over there. Now, like I said, the first thing you want to do is identify the hypotenuse, and that's going to be the side opposite the right angle. We have the right angle here, you go opposite the right angle. The longest side, the hypotenuse, is right there. So if we think about the Pythagorean theorem, that a squared plus b squared is equal to c squared, 12 you could view as c. This is the hypotenuse. The hypotenuse, the c squared is the hypotenuse squared. So you could say 12 is equal to c. And then we could set these sides, it doesn't matter whether you call one of them a or one of them b. So let's just call this side right here. Let's say a is equal to 6. And then we say b, this color b, is equal to question mark. And now we can apply the Pythagorean theorem. A squared, which is 6 squared, plus the unknown b squared, plus b squared is equal to the hypotenuse squared, is equal to c squared, is equal to 12 squared. And now we can solve for b. And notice the difference here. Now we're not solving for the hypotenuse. We're solving for one of the shorter sides. In the last example, we solved for the hypotenuse. We solved for c. That's why it's always important to recognize that the a squared plus b squared plus c squared, c is the length of the hypotenuse. Let's just solve for b here. So we get 6 squared is 36 plus b squared is equal to 12 squared, that's 12 times 12, is 144. Now we can subtract 36 from both sides of this equation. Subtract 36, those cancel out. On the left-hand side, we're left with just a b squared is equal to, now 144 minus 36 is what? That is 144 minus 30 is 114, and then you might subtract 6 is 108. So this is going to be 108. So that's what b squared is. And now we want to take the principal root or the positive root of both sides. And you get b is equal to the square root, the principal root of 108. Now let's see if we can simplify this a little bit. The square root of 108. And what we could do is we could take the prime factorization of 108 and see how we can simplify this radical. So 108 is the same thing as, let's see, it's the same thing as 2 times 54, which is the same thing as 2 times 27, which is the same thing as 3 times 9. So we have the square root of 108 is the same thing as the square root of 2 times 2 times, actually, I'm not done. 9 can be factorized to 3 times 3. So it's 2 times 2 times 3 times 3 times 3. And so we have a couple of perfect squares in here. Let me rewrite it a little bit neater. And this is all an exercise in simplifying radicals that you will bump into a lot while doing the Pythagorean theorem, so it doesn't hurt to do it right here. So this is the same thing as, the the square root of 2 times 2 times 3 times 3 times the square root of that last 3 right over there. And this is the same thing. And you wouldn't have to do all of this in your head. Well, all of this on paper, you can do it in your head. What is this? 2 times 2 is 4. 4 times 9, this is 36. This is the square root of 36 times the square root of 3. The principal root of 36 is 6. So this simplifies to 6 square roots of 3. So the length of B, you could write a square root of 108, or you could say it's equal to 6 times the square root of 3. This is 12, this is 6, and the square root of 3, well, this is going to be a 1 point something something, so it's going to be a little bit larger than 6.
Okay. Explain it well. Any question? No? Great. So I think we did that, didn't we? No. No. Okay, let's look at page 545. Example 5. Again, he has given us a right triangle and the hypotenuse is C. We have the other two sides. So we just put it in a formula. C squared is equal to A squared plus B squared. We find C squared is 225. The square root of that is 50. The example number 6 is very good. It's a very practical example. It says a wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. What is the ramp vertical distance? Take a look at the page next picture on the next page, figure 10.17. So it says the length of the wheelchair ramp is 122 inches. The horizontal length is 122. It wants to know what's the vertical line. It helps you to know these things when you want to build a ramp for your home or whatever. So here we have, again, you apply the Pythagorean theorem. So we have the hypotenuse is 122. We want to find the side x, so x squared plus 120 to power of 2 is equal to 122 to power of 2. And when you do the multiplication and solve the problem for x and get a square root of 484, you get x is 22. So for such a ramp, the vertical part should be 22 inches. Okay. Let's just look at, and I think, exercise 10.2 is the same thing. For example, number 8, if you look, if we have that angle is 130, angle number 1 should be 50. Yeah. At the bottom of page 546, number 8. Okay. Okay. So, and then once we have that, if 1 is 30, 1 is equal to 130 degree, then let me also, the angle number 4 is also 130 degree. So number 2 is 50. Then you add them up and subtract from 180, you get angle number 3, which would be 80. Again, look at number, I think it's 20, yeah. That figure that you can see, again, you have that larger side 15, and you have, that's like the example of the man standing in front of a light pole. You have the smaller part, AB is equal to 3, and you have the other side also, ED is equal to 9. if we want to find and we have the CB is equal to 3. Again, you use the law of the property of the similar triangle. 9/3 should be the same as, let's see, what can we do? 9/3 should be the same as, okay, 15/3. Okay. 9/3, well, which we already know the answer. So if that's 9, if that's 15, if I want to find, okay, no, let's do it this way. 9/3, it should be the same as 80/3, and then you find 80 and subtract 3, you can find what's the length of E. You follow me? All right. Let's move on. Okay. Did you follow? Do you have any question?
Yeah, why 80?
Okay, let's see. Let's go back. We have to find the sides that are in front of equal angles. Okay, that we know the line CB and the line ED are proportional. You can call C/3/9 or 9/3, doesn't matter. Okay, so let's say E/D is the ED, the line ED, or ED/CB is equal to, now think of the larger triangle, AE/AD. AE, no, wait. I will not. No, not AE. AD/AB. Okay, do you follow me? So the line ED from the larger triangle over the line CB from the smaller triangle is equal to line AD, that lower side of the larger triangle, over AB. Okay, you follow me? So ED is 9/CB3 is equal AD, which is, we don't know, over AB, which is 3. All right, so 9/3 is 3, and 80/3, you just multiply both sides by 3, you get 80. That 80 part, that part is 9. So the other part that doesn't tell us is 6. You follow me? Is that clear? Okay. Now we come to polygons, perimeters, and tessellations. For finding relationship between the area and perimeters. Like basically, the perimeters, like if you have this triangle, you just add 1 + 1, 2, 20 + 20, 40. So the perimeter is 40, the area is 20 units, whatever units. Okay. This is 4, the side times the length, it gives you the area. Add these two together, multiply by 2, you get the perimeter. When you have a square, then 6 times 4, 24, 6 times 6, you get 36. The square units a square. All right. Okay, let's go to page 551. Example 1. It tells us, and you have that table 10.3 with different shapes and their names, parallelogram, rhombus, a rectangle, square, and trapezoids. Okay. Example number 1, it says if you have a rectangular field in figure 10.28, okay, has a length of 42 and a width of 28 yards. If the fencing costs $5.25 per foot, find the cost to enclose the field with fencing. Okay, so what are we looking for? Area or perimeter? Perimeter. So we have both sides, we have the length and the width, we add them together, multiplied by 2, we get the perimeter is equal to 140 yards. All right. Now we have to convert that to feet because the fence is in the unit for the fence is $525 per feet. So here, remember, this is something, remember, when you make the conversion, the thing that you want to get rid of, 140 yard times the next fraction, the denominator should have the yard because you want to get rid of the yard. So 1 yard is 3 feet. So you write 3 feet over 1 yard. That's the key. So the yards cancel out. So it ends up to be 420 feet, and then multiply that by $5.25. You get the cost of $2,205. $2,205. Okay. That's basically, you might find, ask yourself, is asking for perimeter or area? Then make sure the units are correct. And when you went to do the conversion, remember that you want to, if it's in yard, you have to multiply by a fraction that the yard is in the denominator. So the 2 yards cancel out. All right, let's watch this video also. This is a good one.
I've got a square here. Say it's right like that. What makes it a square is all of the sides are equal, and I haven't gone in depth into angles yet, but these are at right angles to each other. I'll just draw it like that. That means that if this bottom side goes straight left and right, that this left side will go straight up and down. That's all the right angle really means. Let's say that the side down here is equal to 8 meters, this side right here. And this is a square. And I were to ask you, what is the area? What is the area of the square? Well, the area is essentially how much space this square takes up, let's say, on your screen right now. So it's essentially a way of measuring how much space something takes up and on kind of a two-dimensional surface. A two-dimensional surface would just be this computer screen or your piece of paper if you're also doing this problem. An analogy would be if you had an 8 meter by 8 meter room, how much carpeting would you need? It's kind of the size of the space you need to fill out in 2 dimensions on some type of surface. So the area here is literally how much is this size that you're filling up. It's very easy to figure out for a square. It's literally going to be your base times your height. This is true for any rectangle, but since this is a square, your base and your height are going to be the same number. So it's going to be 8 meters. So your area is going to be 8 meters times 8 meters, which is equal to 8 times 8 is 64. And then your meters times your meters, you have to do the same thing with your units. You get 64 meters squared. Or another way of saying this is 64 square meters. And you might be asking, where are those 64 square meters? Well, you can actually break it out here. So let me draw it a little bit bigger than I originally drew it. Probably should have drawn it this big to begin with. So let's say that's my same square. Let me draw it a little bit. So let me divide it in the middle. Let me say we divide them again. Divide each side again, just like that. Could probably do it neater, and let me do it one more time. divide these just like that, and then divide these just like that. There you go. Okay, now the reason why I did this is to show you the dimensions along the base and the height. So if you show, we said this is 8 meters, and notice I have 1, 2, 3, 4, 5, 6, 7, 8 meters. And the same thing along the side. 1, 2, 3, 4, 5, 6, 7, 8 meters. So when we're talking about 64 square meters, we're literally counting each of the square meters. A square meter is a two-dimensional measurement. That's 1 meter on each side. That's 1 meter. That's 1 meter. So what I'm shading here in yellow is 1 square meter. And you can imagine just counting the square meters. In each row, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 square meters. And then we have 8 rows. So we're going to have 8 times 8 square meters, or 64 meters squared, which is essentially, if you sat here and just counted each of these, you would count 64 square meters. Now, what happens if I were to ask you the perimeter? The perimeter of my square. The perimeter of my square. The perimeter is the distance you need to go around the square. It's not measuring, for example, how much carpeting you need. It's measuring, for example, if you wanted to put a fence around your carpet, kind of mixing the indoor and outdoor analogies, it would be how much fencing you would need. So it would be the distance around. So it'd be that distance plus that distance plus that distance plus that distance. Well, we already know this distance right here on the bottom. We already know this distance is 8 meters. And then we know that the height right here is 8 meters. And it's a square. This distance up here is going to be the same as this distance down here. It's going to be another 8 meters. And then when you go down on the left-hand side, that's going to be another 8 meters. We have 4 sides, 1, 2, 3, 4. Each of them are 8 meters. So you add 8 to itself 4 times. That's the same thing as 8 times 4. You get 36 meters. Now notice, when we measured just the amount of fencing we needed, we ended up with just with meters, just with kind of a one-dimensional measurement. And that's because we're not measuring square meters here. We're not measuring how much area we're taking up. We're measuring a distance to go around. We are taking turns, but you can imagine straightening out this fence, and it would just become one big fence like this, which would have the same length of 36 meters. So that's why we just have a meters there for perimeter, but for area, we got square meters because we're counting these two-dimensional measurements. Now, let's make it a little bit more interesting. What happens if instead of a square, I have a rectangle? I have a rectangle like this. I have a rectangle. Let's say that this side over here is 7 centimeters. And let's say that the height right here, is 4 centimeters. So what is the area of this rectangle going to be? It's going to be 7 times 4 centimeters. 7 centimeters times 4 centimeters. Remember, we could draw 7 rows, right? And each of them is going to have 4 square centimeters. Each of those is square centimeters. So if you were to count them all out, you'd have 7 times 4 square centimeters. It's 4 centimeters. So it's equal to 28 centimeters squared, or squared centimeters. What's the perimeter? What's the perimeter? Well, it's going to be equal to this distance down here, which is 7 centimeters, plus this distance over here, which is 4 centimeters, plus the distance on the top. This is a rectangle. It's going to be the same distance as this one over here. So plus another 7 centimeters. And then you're going to have this distance on the left-hand side. But this distance on the left-hand side is the same as this distance right here. This is also 4 centimeters. So plus another 4 centimeters. And what do you get? You get 7 plus 4, which is 11. And then you have another 7 plus 4. So you have 11 plus 11. So you have 22 centimeters. Once again, it's not a square centimeter. Now let's divert. Let's go away from our rectangle analogy or our rectangle examples, and let's see if we can do the same with triangles. So let's say I have a triangle here. I have a triangle like this. And let's say that this distance right here. Actually, let me draw it like this. I think this will make it a little bit easier for you to see how this relates to a rectangle. Let me draw it like this. There you go. That's my triangle. And let's say that this distance right here is 7 centimeters, right down there. And let's say that the height of this triangle is 4 centimeters. And I were to ask you, what is the area of the triangle? Area of the triangle. What is the area of the triangle? Well, when we had a rectangle like this, we just multiplied 7 times 4. But what would that give us? That would give us the area of an entire rectangle. If we did 7 times 4, that would give us the area of this entire rectangle. You can imagine extending my triangle up like this. And this is a right triangle. This is going straight up and down. This is going straight left and right on the bottom right here. You could say it's a 90-degree angle if you've been exposed to the idea of angles already. So you can almost view it as it's half of this rectangle, and it's not really almost, it is, because when if you just double this guy, you can imagine if you flip this triangle over, you get the same triangle, but it's just upside down and flipped over. So if you think about when you multiply 7 times 4, you're getting the area of this entire rectangle. You're getting the area of that entire rectangle, which we just did up here. But we want to know the area of the triangle. We want to know just this area right here. But you can see hopefully from this drawing that the area of this triangle is exactly half of the area of the entire rectangle. So the area for a triangle is equal to the base times the height. Now this so far, base times height is the area of a rectangle. So in order to get the area of the triangle, you're going to multiply that times 1/2. So 1/2 base times height. So in our example, it's going to be 1/2 times 7 centimeters times 4 centimeters. We know what 7 times 4 is, or we already know it's 28 centimeters. We did that up there. So this right here is 28 centimeters. And then when we want centimeters, and we want to multiply that by 1/2. So it's going to be 14 centimeters, just like that. So the area of this triangle is exactly half of the area of that rectangle. Now, the perimeter of this triangle becomes a little bit more complicated, because figuring out this distance, figuring out that distance right there, isn't the easiest thing in the world. Well, it will be easy for you once you get exposed to the Pythagorean theorem. But I'm going to skip that right now. I'm going to leave that for the Pythagorean theorem video. Let me just give you one more area of a triangle. Let's say I have a triangle that looks like this. This was a very special case that I drew to make it look like half of a rectangle. But let's say we had a triangle that looks like this, a little bit more skewed looking like this. And let's say that this distance down here, that distance down there, is 3 meters. That distance is 3 meters. And let's say we don't know what that distance is, and we don't know what that distance is, but we do know that if we were to kind of drop a line straight down like this, if you imagine this was a building or some type of mountain, and you just drop something straight down onto the ground like that, we know that this distance is equal to, let's say it's equal to 4 meters. So what is the area of this triangle going to be? What is the area of this triangle going to be? Well, we apply the same formula. Area is equal to 1/2 base times height. So it's equal to 1/2. The base is literally this base right here, this triangle. So 1/2 times 3 times the height of the triangle. Or I guess a better way to think of it is an altitude of the triangle. So this thing isn't even in the triangle, but it is literally the height. If you imagine this was a building, you say, how high is the building? It would be this height right there. So 1/2 times 3 times 4. You use that distance right there, which is equal to, 3 times 4 is 12, times 1/2 is equal to 6. We're going to be dealing with square meters. And I really want to highlight the idea, because if I gave you a triangle that looked like this, where if this was 3 meters down here, and then if I were to tell you that this side over here is 4 meters, this is not, this is not something that you can just apply this formula to and figure out. In fact, you'd have to know some of the angles and whatnot to really be able to figure out the area, or you'd have to know this other side here. So this is not easy. Not easy. You have to know what the altitude or the height of the triangle is. You need to know this distance. In this case, it was one of the sides, but in this case, it's not one of the sides. You'd have to figure out what that side right there on the right-hand side is in order to apply this formula.
Good. So it's important to remember that height of the triangle or the altitude can be outside the triangle. Okay. It's from the point to the base. We call these shape polygons any closed shape in a plane formed by three or more line segments that intersect only at their endpoint is called polygon. You know, those lines, they intersect only at their endpoints. Then we have these quadrilateral polygons because they all have 4 sides. So, all right. Now, if we look at set 10.e, okay, yeah. You know, you have that, it's on page 555. You know, these are polygons. Some of them are quadrilateral, some of them are not. But, you know, basically, you can use these, you know, I think they're very simple. You can just apply the laws of perimeter and the area. Some figures like, let's say, if you are dealing with number 22, if you want to find the area, it has given you all the sides. You know, you think of it, you know, divide it into two rectangles, and you know, from that, can you see that? You know that? Do you see that? Okay, right. You have this here, 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 here. Actually, think of these 2 rectangles, and you have all these sides. You know, that side, the broken line is equal to, is the same as that, and that is 5. So this is 5, and this side, this whole thing is given you 14. Okay, so if this is 14 and this part is 5, so this part should be 9. Actually, you don't need that, but just in case. And this side here is equal to the other part, which is right in front of it, which is 4. So we have all the dimension for this rectangle, and this one also, they have given us this whole thing 17. So if this is 4, this part is 13. So you have that, and find all the area and perimeter. Okay. Let's go to the next one. You know, something in mathematics and in architecture is called tessellations. A tessellation of a flat surface is the tiling of plane using one or more geometric shape called tiles with no overlap and no gaps. An arrangement of shape closely fitted together, especially of polygons in a repeated pattern without gaps or overlapping. And in mathematics, these tessellations can be generalized to higher dimension. What is a tessellation? Definition is a repeating shape that covers a surface without overlapping or leaving gap. The word comes from Latin tessera, which means a small stone cube. And the earliest ones that we can find are the mosaic pictures on the floors in the old Roman building. This is metamorphosis because you can see it changes from one shape to, to animal to birds. So it changes its form, metamorphosis. Okay. Now you can watch this video. This is a good one.
Tessellations. Tessellations are tiling patterns formed of shapes with no gaps in between. Regular tessellations are formed of regular polygons, and we can see if a regular polygon will tessellate by looking at the interior angles. The vertices or corners of the shapes should all form a 360-degree angle in order to tessellate. You should be able to divide 360 by the interior angle of the polygon with no decimals. So here we have an equilateral triangle, interior angles of 60 degrees. To find out if this shape tessellates, we divide 360 by 60, which gives us a whole number. This tells us that this shape tessellates. Here we have a regular pentagon with interior angles of 108 degrees. This does not divide fully into 360, as we are left with a decimal number. Therefore, this shape does not tessellate. Have a look at these regular polygons and work out if they tessellate. Pause the video whilst you figure it out.
Okay. All right, just something to know. Again, you got to know these formula regarding area and the perimeters for circle, trapezoid, square. Square and rectangle are easy. Triangle are easy too. Remember what the circle area is pi r squared, and the circumference is 2 pi r. All right. And remember the radius is half of the diameter. Remember for trapezoid, that's h, that's the height. Okay. Any question? Nope. We can continue. Okay, let's look at page 558. Example 1, that's just like the one I did on the board. It says, if look at figure 10.37, find the area of the path, the whole thing. So you divide it into two rectangle, I'm sorry. Basically, let me draw the shape. And, okay. So think of it as two rectangle. Just imagine there's a line there. And what are the sides that we have? We have three, this part is 3 feet. This one here is 13. Let's say this is 6. This is 3. And that's it. Okay, and that's all we need, actually, because if this is 3, that tells me that this part is 3 also, okay? And if this is 6, this should be 6 too. So if this is 3, this should be 3. And if this is 13 and 3, what should this be? 6. So you have all the sides. You can, find the area. It's 13 times 0.3 for that part, and 6 times 0.3 for this part. Add them together, you get the whole area. For perimeter, you add 3 plus 16 plus 3 plus 6 plus 3 plus 6 plus this part, 13. This I mentioned. Okay. Example 2, page 50. Okay, here says, what will cost to carpet a rectangular floor measuring 12 feet by 15 feet if the carpet costs $18.50 per square yard? Okay, so we need to find the area. All right, but we need to also convert it to yard. Okay, so we know 1 yard is equal to 3 feet. So that 3 feet should be in denominator. So I multiply by 12, the 2 feet, those were canceled out, and I get 4 yards. You see that? 15 feet, again, multiply by 1/3, you get 5 yards. Now, multiply 4 by 520, and then multiply 20 by 1850, you get $370. All right. Look at example. Any question? No. Look at example 3. Using formula for parallelogram area, and the formula is in that green shaped box. The area of a parallelogram is A is equal base times height, B times H. So the base is 8 centimeter, the height is 4 centimeter, you just multiply them together. The area of a triangle, as was mentioned in the video, is base times height divided by 2. The area for trapezoid is A is equal, you add the base plus the top side, A plus B, times the height, and divide the whole thing by 2. All right. Page 561, we already did that. Yeah. Which is, it says example 4, it has given you the base of the triangle. It says in figure 10.42a, the base is 16, the height is 10. So find the area, you just base times height over 2 is 18 meters square. In figure 10.42, the base is 12, the height is 9. Remember, it's outside. Okay, so base times 9 over 2, you get 54 inches. All right. For circle, the circumference is the pi number times diameter, or twice the radius, or 2 pi r. Let's look at 563. Example 6. Find the circumference of a circle whose diameter measure is 10 inches. Okay, if the diameter, I'm sorry, find the circumference of a circle in figure 10.47. Okay, the diameter is given 40 yard. So pi times 40 yard, you get 125.7 yard. That's a circumference. All right. And the area is pi times radius to power of 2. Look at, for example 8 at the bottom of page 563. Example 7, let's look at that before we go there. It says how much trim to the nearest tenth of foot is needed to go around the window shown here. All right, the trim for the window. The trim covers 6 foot bottom of the window and 8 foot side and a half circle called semicircle. So we need to find the circumference of that semicircle, but we know the diameter. The diameter is what? 6 foot. It's the same as, think of it as a rectangle. The diameter is 6 foot. So you multiply the radius is that's the diameter. Actually, we don't need the radius. Pi times diameter. What we have to divide it by 2 because it's a semicircle. So you get 9.4, but then you add that to 8 plus 6. So you get the trim for the whole window. All right?
Yeah.
Example 8 is which one of the following is the better buy? A large pizza with 16 inches diameter for $15, or a medium pizza with 8 inches diameter for 7.50 cents. When we are talking about the pizza, we are talking about the area. Which one gives you more pizza? So you find you have pizzas are in shape of circle. Let's assume that. So you have 16 inches diameter for one circle. The other one is 8 inches. So you find the area of these two pizza. You divide the radius. You have the diameter divided by 2. You get the radius. So the large pizza area is 200. With approximation, 201 inches square. The medium pizza is 50 inches square. Now, to find which deal is better, you have to find the price per unit. So you divide $15 by 64, or by 64 pi, or by 201. The cost would be, the average per unit would be about 7 cents. For the medium pizza would be 15 cents. So the large pizza approximately 7 cents per square inch, and the medium pizza costs 15. So the large pizza is definitely a better buy. All right. When we think of volume, let's go to page 569. Again, you got to remember some formula, like the volume of a rectangle is actually adding up, stacking up the area of the base. So you multiply the length by the width times the height. The same with a cube. You find the area of the base, multiply by the height. It should be 3 times, whatever S is multiplied by 3. Okay, if you look at example 1, find the volume of a rectangle solid in figure 10.50. 10.50 here. So you have the length 6, the width 2. So 2 times 6 times 4 becomes 48. 48 meter cube. Okay. Example number 2. Solving a volume problem. You are about to begin work on a swimming pool in your yard. The first step is to have a hole dug that is 90 feet long, 60 feet wide, and 6 feet deep. You will use a truck to carry 10 cubic yard of dirt and charges $12 per load. How much will it cost you to have all the dirt hauled away? So you need to find the volume of your pool. So you multiply, or first let's convert them to yard because the price is per yard. So 90 foot again, it would be 30 yard. 60 foot will be 2 yard. So you multiply the base, the length times the width times the height. So you get 1200 yard cubic. Okay. Then it says $12 per load. Charges okay, it can carry 10 cubic yard. So for every 10 cubic yard, it will charge you where is it? $12. Okay, so I want to now I have 1200 yard cubic square. I divide it by 10, I get 120 trips. So the truck can carry only 10 cubic yard. I have 1200, so I divide it by 10, I get 120. So there has to be 120 trips. And each trip costs me $12. So you multiply by 12, you get $1,440. You follow? So we find the volume of the pool. We know the volume of the truck, how much it can carry. We find out how many times it has to carry, and we know price per each trip. Then we find the total cost. Let's look at page 571, examples 4 and 5. Find the volume of cylinder. Okay, volume of cylinder is basically find the area of the base multiplied by the height, the height of the cylinder. So if that cylinder is 20, the diameter or radius, it's a radius. So I find a pi r square. It gives me the area of the cylinder, that base, and multiplied by 9 by the height. You get the volume. Okay. Example number 5. Finding the volume of a cone. Now, the formula for the cone is in that green table. Pi r square times h, exactly like the cylinder, but now divided by 3. We have this radius, pi times 7 to the power of 2 times 10 and divided by 3. You get the volume of the cone. All right. Well, any questions? Let's see. Another one. There's one more. 572. Example 6. An ice cream cone is 5 inches deep, and so that's a height. Okay, and that's the h, has a radius of 1 inch. A spherical scoop of ice cream also has a radius of 1 inch. If the ice cream melts into the cone, will it overflow? Well, let's find out. So basically, we want to find the volume of that sphere and volume of that cone. The volume of cone, we said, is pi r squared times h divided by 3. And we have all the numbers. So the volume of the cone is 5 inches cubed. The volume of a sphere, you have got to, the formula is in the previous page, is 4/3 of pi r cubed. So again, you plug the numbers, you end up with 4 inches. So no, the sphere is less than the cone, the volume, so the ice cream will not overflow. Okay. That's it. Just familiarize yourself with those formula and practice, and you do good. Any questions?
To memorize. all of that?
Not all of them, but main one. Remember the main one. Okay. All right, guys. Well, God bless you. So please send me your PowerPoint presentation. Just in case, bring your laptop. Just in case, because my computer uses PowerPoint. I don't want there be any problem. But if you may send it to me, I will download it. I can check whether it can be used here or not.
Do you use Populi? Did you do
Yeah.
that through Populi?
Yeah.
Because I can send you the PDF and you just open the PDF through Populi.
Okay, all right, whatever.
works?
That's fine. That's
Okay.
fine. Okay, guys, take care. See you next week. Have a good week.
Thank you, you will.